And it's okay now, or please give me a quick feedback by dropping some message from the chat. Okay, yeah, we start now. And so we discussed one example in last class, and today we will continue our study of the examples. And so in last class we spent a lot of time discussing in detail about how to solve this one. Let me turn to example 1. This is, this is exchange optimal, exchange economy. We have some X goods and some Y goods. And then the problem is, what's the optimal way of allocating X and Y between Alice and Bob? This is how much we give of good X to Alice. This is how much to good X to Bob. And this is the preference or the utility function by each of them. And then 2 questions, 2 problems. 1, what's the optimal solution? That is, how much of what should I give into whom? Okay, how much of good X given to Alice and how much good X given to Bob, and so on and so forth for good Y. That is, we ask to find all the solution, all the good solution, sorry, all the exchange optimal solution. The second one is, if we're giving social wave function, this is about some sort of a value judgment at a society level, and we give some value to the parameter alpha. Alpha measure how much we care about Alice, and 1 minus alpha measure how much we care about Bob. And alpha is some number between 0% to 100%. And then in last class, we have already solved this problem step by step by using the idea for marginal rate substitution being the same at exchange optimal. And then we go through all the, this is some boring and stupid process of mathematics. And we went through the process, and eventually we find here, that's what we get. Let me just to refresh your memory, just in case you forget it. This is what we found. The curve inside the box. At any point along this curve is a good solution, is 1 exchange optimal. So this is the answer to the first question. And then for the second question, let me delete. Oh, sorry, I forgot to make a record.
Recording in progress.
And then so let me. So we solve this example by firstly look at the exchange optimal, and then we find the solution. This is this part. We call this partial set. And then for giving social wave function defined by the value for alpha, this one, alpha, measure relatively how much we care about Alice compared to Bob. And if alpha is bigger, is a bigger number, that means we care more about Alice. Let me close the window, it's no. Okay. And When alpha increases from 0 to 1, that means we are increasingly caring about Alice and less caring about Bob. And then this is kind of intuition. So therefore, the solution should reflect such a sort of a political philosophy behind the social function. That is, when alpha increases intuitively, we should give more and more to Alice. And now let's confirm this economic intuition. We find this is the solution. When alpha increase, XA increase, and then basically this is the solution. Okay, this part. So when alpha increase, both XA and YA increase. And when alpha is running through from 0 to 1, then the solution is running through from this point, and then increase until Alice take all when alpha is eventually going to 100%, going to 1. So, this kind of a curve is very consistent with our intuition. And now we are dealing with a more general economy and to identify the so-called top level optimal, the overall optimal solution, how to organize social economic activities in a way to make best use for the resources for the whole society. So, this is the sort of story. We are facing this story. We try to give a good answer to such a story. So let's look at, again, let me clean up for this one. Let me see. And today we are dealing with, so this is another solution. We just to see that the silly solution. Don't take this approach. This approach is usually very much appreciated and loved by mathematicians, not by economists. We are not that good at math. We are good at economics. And this solution is actually a little bit stupid, silly. Okay, now let's turn to another example. And clearly, this example is expanded from the first example. In the first example, we are dealing with part of this problem. In the sense, we are only care about this part, giving the preference and some goods X and Y. That is, we don't care about production. We assume that production is already done. It's already, all the goods produced already. This one equal 100. This one equal 100. No production. And then we are dealing with what's a good way to allocate goods X and Y between Alice and Bob. That's what we have done in example 1. And now, let's allow for production. And the constraint, we have some resources. So far we are theoretical discussing about the top level optimal. We always assume that we have resources, labor, and capital. And here, for this example, we simplify the story by assuming we have only one kind of a resource. We have only labor. We have some, for example, 1,000 or 1 million workers. This is kind of, we normalize the quantity of labor by 1. Suppose we have only 1 unit for all the labor resource. And we can allocate the labor either to produce X or to produce Y. And the production function is very simple. If we are using one label to produce X, we produce 1X. If you use 100, we produce 100. So this is so-called identity production function. Sorry, this is O. So this is the so-called identity. That is, we can train the equal quantity of labor, the quantity of labor into equal quantity of goods X. This is the production function, or if you like, you can put it this way. This is the function F is the production function, and Lx is the input. Given such input, the output equal to X, but this one equal to the X itself. So therefore, so this one is so-called, identity function. So here we simplify the production technology not only by assuming that we only need one resource, one input, that is the labor, but also we further simplify the production technology by formulating a so-called identity, a very, very simple production function. So if we allocate this much Lx, we can produce the same quantity as amount of labor for goods X, and the same for goods Y. So this part is about production, this part. And this part, after we organize the social production, this part is about exchange. So therefore, this simple economy naturally bring together the two levels for social and economic life. And one part, this is about the so-called exchange. It's actually about consuming, about consumption. And this part is about production. And bring together that so-called top level. Excuse me. So now we are facing the problem. What's the top level? Basically, given such economy support this Marcos society, half of the population is of Alice type, and half of the population is Bob type. Alice care more about goods X as twice as goods Y, and Bob care more about Y. So basically, the population in Macau are different. Half is type 1 or type A, and the other half is type B. That's the population. And also we have some resources, and we have some technology by which we can turn the resources into goods. Okay, so therefore, this is technology. Technology means we can turn resource into goods. Okay, how to organize the social production and exchange in a way that we are doing a good job. We are doing a great job. What's the Pareto optimal solution? So this is the first question. The second question, very similar to the first one, to the first example, is Given again the social wave function alpha, this is very simple. The so-called the Bessemer social wave function. We just sum up the utility, but we give some weight. This is average, sort of average between Alice welfare and Bob Alice, but that's weighted average. And again, this major sort of political philosophy, who will carry more compared to other members in the society. And now, so that's the two problems we are facing. One, in general, what's the Pareto optimal solution? But here, just a little bit careful. When we talk about exchange optimal, the solution is only about how much of what is given to whom. Nothing to do with production. But now we are dealing with top level. So therefore, the good solution or the Pareto optimal solution is not only about consumption, but also about production. How much resource we are going to put into use for producing the goods, the two goods. So this is optimal. And secondly, what's the optimal solution? Solution means how to organize social production, how to organize consumption. So now let's look at the first one. The first one, because we have done a lot of work, a lot of exercise in solving example 1. So therefore, we can quickly find the solution for the second example. Oh, let me, I think it's a little bit loud. Okay, now let's look at what's the good solution for the top level. So again, at the top level, what condition we can make use of? And we are making use of this condition. At the top level, marginal rate substitution of everybody equals the marginal rate of transformation at a society level. And that is here. This is the PPF. But in our example, this PPF become very simple because become the linear function. And then at each point along the PPF, we can construct some Edwards box. And for each box, we can identify such a point where the marginal rate substitution for everybody is the same as the marginal rate transformation. And so we are making use of for this condition. Basically, this is a straight line, this is not. They parallel with each other. And so now let's turn back to our example. Okay, here it is. So firstly, let's identify how the PPF looks. The PPF is rather simple because this number equal X, this number equal Y, because X equal Lx. So therefore, the production possibility is X plus Y equal Y. So therefore, if we want to produce one more Y, we have to give up one more X. So therefore, dy over dx equal -1. So in other words, the marginal rate of a substitution in the technical sense in social production between X and Y equal to 1. So therefore, you can see for this example, the so-called marginal rate of transformation is rather simple, very simple, equal 1. Basically, you can give, you can give up some x in order to get more y. So the exchange rate is 1 to 1. It's quite simple. So this is a lovely result, can simplify all the calculation. And now to turn to the individuals. And for the individuals, this is what we have done already for Alice. The marginal rate of, just in case you forget it. For Alice, the marginal rate of substitution equals double y over x. For Bob, it's half y over x. Okay, so we have done that so that we don't need to repeat that job. We just, okay. So here, so therefore, the marginal rate of substitution for Alice is this number. Sorry, this result. For Bob is this result. Okay, any question? No? Probably, okay. And so therefore, at the top level, optimal, the 3 numbers must be the same. This one, at the society level, I mean, for social production, this is marginal rate of transformation or substitution in technical sense between x and y equal 1. The 3 numbers must be the same. So what does this mean? That means at the so-called top level optimal, we have some very, very good relationship between how much x Alice should consume and how much y Alice should consume. So these 2 numbers have equals, and the ratio between the 2 numbers equals 1. I mean, also times 2. So therefore, from this one, before we move forward, we have already got some feeling in economic terms. That is, at optimal, then for Alice should consume as twice x as y. XA equal double YA. For Bob, YB equal double YXB. So this is very useful result. And also, we have some resource constraint. And the resource constraint is formulated in terms of labor. We have such many labor. And how much we can, use as input for producing X, how much to produce Y. But let's train this constraint as one in terms of goods. And this one, Lx equal X, but X equal how much we give to Alice and how much we give to Bob, both for goods X. So therefore, X equal XA plus XB. And so therefore, if we put together equation 1, equation 2, and here we have 4 variables, XA, XB, YA, and YB. We have 3 equations. So therefore, intuitively, if we have 4 equations and 4 variables, we usually have a unique solution. The solution is only 1. But now, if we have more variables than the equations, the solution would be a kind of a curve, pretty much like what we have done earlier. For the exchange economy, we find the solution is like, it's not one point, it's rather a set, this curve. And here, quite similarly, the solution is a set. Let me turn back. Okay. So therefore, equation 1 and equation 2 put it together, we have 3 equations and 4 variables. And now let's simplify the formulation by basically plugging equation 1 into equation 2. And how to do that? We get this result. This is the relationship between y and x for Alice and for Bob. We put the two results and into equation 2, then you will find YA equals half XA. Half XA plus XA, this equals 1.5 XA. So this number, let me emphasize, make sure everybody can clearly understand. So this one, you plug this one into this one. So therefore, this one becomes half XA. Half XA plus XA equals 1.5 XA, right? And now YB, I should use a different color. YB equals double XB. So therefore, this is the single XB. So therefore, we have a triple XB. So now we get some relationship between how much X Alice consumes and how much Alice Bob consumes. And now we almost solve the problem. And so now from this one, we can get 2 important observations. The first observation is how much XA we can have. Clearly, we can give Alice nothing. So therefore, XA could be 0. But the point is how much at maximum we can give to Alice. And this, we want to give more to Alice, then we should give less to Bob. And how much at minimum we can give to Bob is 0. So therefore, if this one equals 0, and XA equal 2/3. So therefore, XA must be some number between 0 and 2/3. And any number is possible. This is the first point. So the second point is for any XA, sorry. So for any XA taken from this range, any value, so XB equals this number minus this one, and divided by 3. So therefore, XB equals 1/3 minus half XA. So this is the relationship between XA and XB. And YB equals double XB. So therefore, this one double means this number becomes 2/3. This number becomes single XA. So now put this one, and this one. If you look at the 3 equations carefully, you may find we have already formulated each of YA, XB, YB as a function of XA. At the same time, this is the range of XA. So this is the solution. I just circled. circled the four results. The four results combined together give us the so-called top level solution. So now, so this is the solution. So you put it together the four equations we just mentioned. For any XA, oh, still let me mark by a different color. So XA could be any number taken from this range. For any possible value of for such XA and YA equal half, and YXB equals this one. This is XB equals this one. So this is XB, this is XB. Okay. Just put them together. This is YB, this is YB, put them together. So therefore, for any XA, this is the solution for XB and YB. So altogether, this is the Pareto optimal solution for such economy at the so-called top level. You know, this part is about consumption, or we call exchange. It's actually about consumption, about you and me, how much we eat and drink, and nothing to do with production. And now this part is about sort of production. How much for good X? You know, the value for good X is also the value for labor input in producing X. So therefore, this one is not only about how much X we produce for the whole society, but also about how much labor we allocate to the production for X. How much we get this one plus this one, that is this is XA, this is XB. So this term plus this term altogether clearly equals 1/3 plus this is the positive single XA, this is the negative half. So therefore we get positive half XA. So we should organize our production of X at this level. And so again, let me emphasize, XA is not fixed point. It's not a fixed point. It's instead is a variable. As XA can be taken from this range. Any number is okay. Any number is acceptable. So therefore, when XA equals 0, this term disappears. We get 1/3. When XA equal to 2/3, this one equal to 1/3 plus 1/3. That's 2/3. And similarly for Y. So here you may find something interesting. You know, technically speaking, we can produce 1X. You know, we use all the labor we have. We produce nothing in Y. We put all the labor we have for the whole macro society to produce X. We can produce 1 rather than only 2/3. And similarly, we can use a lot of labor to produce Y. So therefore, we can produce some number for X smaller than 1/3. So this is possible for technology and also for the so-called technical efficiency or production optimal, we can produce any number outside this range, either above 2/3 or below 1/3. But now we are considering top level or what's good for the whole society. So therefore, we needed to consider not only production, but also who we are talking about, who we are dealing with. We are dealing with you and me. We are dealing with our preference. That is, we must take into account the people's preference. So therefore, we must consider the so-called top level optimal. Top level optimal means it's not enough to only consider production. You must organize the social production in such a way to make the macro people happy as possible. So therefore, production optimal alone is not enough. We must bring together the production optimal and the exchange optimal. That's why we have such a result. And now if we turn to the social production, what does this one mean? This one means we can produce X, any value for X from this range, from 1/3 to 2/3. In theory, we can also organize our social production any point here. You know, this is, let me again emphasize this. This is the PPF. The whole curve is the PPF. So therefore, technically, we can organize our social production for our society, any point here, but at the top level, again, we have to consider who we are producing for. We are producing for our people, for you and me. So that constraint makes the so-called optimal level production set much smaller. We can produce only this part. Okay. And this part technically possible, but it's not a good solution. The idea is like this. If you look at carefully who we are. Suppose that's you. You care about X and Y. I care about X and Y. So therefore, if we have a lot of X but 0 Y, this number is very, very small. What does that mean? That means we suffer. You suffer. Your utility or your welfare is very, very small number. This is negative infinity. Where A is very, very small, almost to 0. This is negative infinity. 负的无穷大. Okay. So that means your welfare is terrible. It's very, very low. It's not a good thing to do. So that's why, and quite a similar argument for Bob. You know, Bob needed to eat and drink. A lot of water, no food, horrible. A lot of food, no water, also miserable, very horrible. So therefore, for the people, we can't organize the production here. Lot of water, but no food. Lot of food, but no water. It's horrible. So that's why the production top level optimal social production is running from this point to this point. Okay, so let me summarize. This is the top level set about how to consume, about how much to produce, basically running from this point to this point. So now let's turn to the so-called social wave function. For such a social wave function, how to organize consumption and production. Okay, so again, for this one, again, in principle, we have two ways, two methods to find the optimal solution and such a social wave function. Either making use of the result in the first step, that is not a good way to solve it. And pretty much like what we have done about the exchange economy example. And another one is, let's start from the very beginning. That is, we are dealing with such a problem, how much given to X, Alice, or for X given to Alice and given to Y. And we are making use of part of the result we got already from this one. We formulate everything in terms of X A. Okay, so for let me put the two equations in the same page. You can see it. Give me a couple of seconds. Okay. Can you see it? Okay. So, this is Pareto set. And, okay, this is XA. This is, let me again emphasize. So okay, let me turn back to expand this one. So I'm sorry, the size for the text is a little bit small. And so this is XA, this is XA, that's okay. And then now this is YA. How much of the Y Alice is consuming is this number. Okay. And for Bob, let's turn to the boy. The boy consuming this much of goods X, this much of goods X. Okay. And the boy Bob consuming this much goods Y, this much goods Y. Okay. And then we simplify this welfare function, and now we find the social welfare function W is a function of one variable, XA, XA, XA. And XA is taken from this range. Okay, so therefore, the social wave function becomes one variable function. And for the one variable function, we know how to solve for the optimal solution. So now let's simplify this formula. And we put it together. This is double log XA. This one equals log XA. It's a little bit silly for some of you, but just in case some students, sorry, this is a log 2. Okay, So here we have double log A, single log A. So therefore we have triple log A. So we put the 3 outside. So this part comes from this term plus this term and multiplied by alpha, this one. And here, look at it carefully. This number, again, equals right? So why did we do that? Because we want to simplify this part by combining the two terms. At the same time, the coefficient between variable xa equal 1. So therefore, that's why we simplify this one by formulating it as this term minus this term. So now we have this one actually, it should be equal to, if we, alpha equal to log 2. Because here is alpha times log 2 minus alpha times log 2. Here is minus 1 minus alpha and then multiply by log 2. So therefore, but this doesn't matter, just you can just ignore it. And then here you get triple double this term. Here you get a single term. So therefore, put them together, you get a triple. Triple means 3 times this number times log this term. So that again, put 3 outside. And then we get this one. To maximize social wave function is to maximize only this part. So now this part is much, much easier to calculate. And okay, and for this one, you only need to again. So here we only focus on this part. To maximize W is to maximize value for this term. This term, the first order condition about XA is alpha over XA minus 1 minus alpha over this term. Why minus? Because here is a minus equals 0. Okay, then we shift this term from the left to the right. And here you can get a very simple answer. Basically, XA and 2/3 minus XA is proportional to alpha over 1 minus alpha. What does that mean? Basically, you should divide this term into 2 parts. One part is XA, and the rest is another one. Okay, how to do that? You should divide this term into 2 parts. Of course, it's easy to find the answer mathematically from this equation, but for economists, it's much more natural to think about how to allocate this value into two parts. This part given to XA, this part given to the rest, this number minus XA, in the way that XA take alpha percent for the total value, the rest take up the rest, 1 minus alpha percent of the total value. So therefore, XA must be equal to this one. So this, of course, you can calculate this one. It's not difficult. Alpha times this one, 2/3 alpha, and alpha XA minus shift to the right become XA equal to this one. But this one is much more straightforward. You don't have to calculate, just directly write down the solution. And if this XA was XB, this is it was YA. YA equals half XA. So therefore equals 1/3 alpha. XB equals this one. Okay. And 1/3 minus half XA, that is 1/3 alpha. And this is YB. Very similar. Basically, YB equal twice of XB. Okay, so we get the solution. So therefore, for given value for alpha, we find the solution is unique. We have only one solution. Given alpha, we get this one for XA. This is how much goods X Alice should consume at social optimal or top level optimal. This is YA. This is how much Y Alice is consuming at optimal. This is XB and this is YB. Again, turn to social production. How much X we produce or how much labor we allocate to production for goods X equals XA plus XB. Again, this number plus this number equals this one. This is Y. How much of goods Y we should produce. This number plus this number. Okay. And now, if you consider carefully, you may find this number plus this number equal to 1, of course, because that's our PPF. That's our production possibility. And now, let's make some discussion. One discussion is the so-called economic discussion. Another is childish discussion. That is, let's discuss the story pretty much like a case. That is graphic discussion. So what's the economic discussion? When alpha increase, we treat Alice intuitively. More and more we are joking to see, pretty much we are treating Alice more and more like a queen. Alice is somebody, more and more like somebody, and Bob more and more like nobody. And then eventually treat Alice as the real queen when alpha equal 1. When alpha equal 1, what happened? So here, it's really now you come back again. look, when alpha equal 1, what happens? Alpha equal 1, this term equals 0. Alpha equal 1, this term equals 0. What does that mean? That means if we treat Bob as nobody, okay, you know, the weight for Bob for the social wave function is 0. Then that means Bob the waveform doesn't matter, simply doesn't matter. So therefore, we should not care about Bob at all. So Bob will consume nothing. So therefore, this term becomes 0. This term becomes 0. When alpha equals 0, that is Alice doesn't matter. Okay, Alice is completely nobody. So therefore, we give nothing to Alice. This one becomes 0, this one becomes 0. We produce for one person, that is Bob. Okay, so now if we turn this discussion into the graph, into the figure, so this is quite an interesting figure. Let's spend a little bit more time on this one. Let me. So this is our final result. We should organize the social production some point from this range. Okay, so this is the so-called top level production. And where we should go depend on alpha. So alpha, when alpha increase, let's look at sorry, I forgot here. Yeah, good. And here, let's see. Okay, let's put it here. So this is how much X we should produce. X equals 1/3 plus 1/3 of alpha. Okay, when alpha equals 0, so let me put it here, X equal 1/3 plus 1/3 times alpha. So when alpha increase, X increase. When alpha equals 0, X equal 1/3 here. Okay, so when alpha equals 0, we give nothing to Alice. Alice completely doesn't matter in the society. So that is, we should organize the production only for one person. That's our king. That's Bob. For Bob, this is a good solution. Okay, more Y, less X. So that's where we are. And when we care more and more for Alice, we should produce more and more for Alice. And so alpha increase, that is, Alice becomes more and more important. We should produce more and more X. Why? Because Alice, for Alice, remember you can turn back. I hate to turn back. And you know, for if you look at the preference, the utility function, you will find for Alice, X is as twice important as equals Y. So in other words, Alice care more about X and Bob care more about Y. So therefore, when we care more and more about Alice, we should organize our social production toward X and a little bit further away from Y, because our queen, Alice, care about X. So therefore, when we care more and more about Alice, we should produce more and more X. That's where we are. Because Alice loves X and Bob loves Y. But now, Alice is more and more important. So therefore, X is more and more important. We should go this way. And until alpha becomes 1, that is Bob doesn't count. Bob doesn't matter. We produce for everything for one person. That is for the true queen. That is Alice. We are here. And what's happening over the process? Over the process is like this. Look, when alpha equals 0, we are here. At the same time, XA equals 0. Because when alpha equals 0, Alice doesn't matter. She doesn't count for the society, for the social welfare. So therefore, we are starting here. When Alice matters more and more, we are producing more and more X. So therefore, this one increases with this one. At any point, for example, I don't know, probably at this point, and we are producing probably this much. Okay. For some alpha, we decide to produce this much X. At the same time, this much for Y. Okay. Suppose for some value for alpha, we are here. So therefore, we produce this much. This is X. This much. This is for Y. So therefore, this is Edgeworth box, right? For this Edgeworth, Edgeworth box, this is the PPF. So therefore, the marginal rate substitution equal 1. For this curve, at this point, for this curve, probably the Pareto set is like this. Only at this point, sorry. Yes, it's very bad. Let me redraw. No. So here, at this point, this is the Pareto set. And at this point, what happened? The two persons, Alice and Bob, share the same marginal rate substitution. This is for Alice, and another one for Bob. Oh, let's be very careful. Okay, good. So this is for Bob. They are sharing the same Okay, wonderful. So this is the marginal rate substitution. This marginal rate substitution equals the marginal rate for transformation equal 1. At this point, for this given Edwards box, we get the so-called exchange optimal. This exchange optimal together with the production optimal and together with the top level condition, marginal rate substitution equals the marginal rate transformation equals marginal rate substitution for everybody. We get this one. So therefore here, look, this is a very simple figure, but what's behind the figure is a very complicated social and economic process. It's about how we are going to organize our social and economic life. And the way we are organizing our social economic life reflect the political philosophy that measured by the value for alpha. Okay, our value judgment determines how we organize our social economic life. So this is a very simple example, but this example, I hope, can give you quite a lot of insights into how the society is operating, and also about why the people care so much in the presidential election. Who will be the boss for the country? Who will be the president? And that will determine who we are organizing production for. Look, if we care more and more about Alice, we should produce more and more what Alice care about. Alice care about X compared to Bob. So therefore, if we find some candidate who is running for the president is caring more about Alice, then after that guy or that lady is elected, the whole society will be operating in such a way to produce more X. Okay, depends on how much we care about Alice. Depends on how much that person or that lady or that guy who are the lucky boy or girl next president. So look, this is a very simple example, but it tells us why people care about politics. And because politics turn into economic life. And so on the other hand, and if, for example, Alice is a civil society, Bob stands for the military stuff. So in Chinese, this is we call civil society. Let me just for discussing, for your better understanding of the economic story. And okay, we are running for time. Probably we should not go very far. But again, this is very important for your understanding. Let me write some words to help you understand. For example, Alice is represent some平民社会, okay? That is the people just like you and me. And Bob is some special group of people, 利益团体, okay? 特殊团体, like for example, the soldiers, the army, the military people, they are not the. Then, if we give a big value to alpha. That is, we are running the whole society more and more for the civil people, for the civilians. And we give less and less value to alpha. We're running society more and more for the interest group, for the special group, special people. So this is what's going on behind this picture in come back to reality. So that's why the social welfare function matters so much. So this is an example. So in general, let's turn back to before we conclude. And we conclude not only this class, but also for our study or for Pareto optimal. So next class, we are going to turn to a completely new topic. So look, the picture we just covered is a special case for this one. In general, PPF is a curve, not a straight line. And in last example, this becomes straight line, just as an example to simplify our discussing. And in general, we have such a solution. So therefore, that example is really just an example. That's a special example, special case for the general situation. Oh, we spent the whole class for, but yeah, probably this topic deserves this much time. Okay, before you go, any question? I'm sorry, so we have much less time today than normal for questions. Do you have any question to ask? Any question? You can ask in, just use the microphone quickly, and that will take you more time if we, by writing, and just speak up. And you can ask question in Chinese and or in English. No? It's clear enough or? Okay, if no question, that's all for today. And from next class, we should have the normal teaching model, right? We can have the normal teaching lifestyle in the classroom. We can make much more use for the whiteboard. We have much more comfortable discussing with each other. And we also will turn to a new topic about so-called welfare change. And okay, we are running for time. We can't go any further. Okay, if no question, take care and goodbye. Any question? If no, bye-bye.